Today we're going to explore built-in functions, which I like to think of as your essential Python toolbox. A common question for beginners is, why should we use built-in functions? The answer lies in efficiency and reliability. These functions give you instant access to pre-written code that is already tested and ready to use. Instead of reinventing the wheel for every task, you can use these tools to perform complex operations with just a single line of code. Throughout this session, we'll distinguish between functions, which are our single tools, and modules, which are larger organized toolboxes containing many related functions. Think of built-in functions as a set of professional tools that come pre-installed and ready to go the moment you open Python specifically. These are pre-written code blocks. The beauty of these functions is that you don't need to define them or understand the inner complexity before using them. They are designed to be used immediately to solve common tasks. You might already be familiar with our I/O tools. For instance, print is used to display output, while input allows us to collect data from the user. These are essential for any interactive program. Then we have math tools like abs for absolute values, round for rounding decimals, and max to find the highest number in the list. They save us from having to write the mathematical logic ourselves. Lastly, we have type conversion tools. These are vital for changing data between formats, like converting a piece of text into a number so we can perform calculations. Let's dive into the specific tools you use most often. This list represents the foundation of your Python workspace. These are pre-written blocks of code. Think of them as high-quality tools in a toolbox that are already sharpened and ready for you to pick up and use immediately. Looking at this table, you can see familiar names like print and input for communication. We also have mathematical helpers like sum, max, and min that handle complex calculations in a single step. Let's dive into two of the most essential tools in your Python toolbox for checking your data: the len and type functions. First, we have the len function. Think of this as your digital tape measure. It simply counts the number of items in an object. It is incredibly versatile, working with lists, tuples, and even strings to tell you exactly how many elements or characters are present. Next, we use the type function when we need to identify the nature of our data. This function checks the variable's class. It helps us confirm if we are dealing with an integer, a float, a string, or a list, which is crucial since Python handles each of these differently. So why do we bother inspecting data so frequently as shown here? It is essential for finding logic errors and preventing bugs. Let's move on to a critical skill in Python: handling user input and managing type conversion. There is a very important rule to remember. The input function always captures data as a string. Even if the user types in the number 25, Python sees it as text. This means you can't perform math on it right away. To solve this, we use the casting toolbox. Casting is simply the process of converting a variable from one data type to another, like turning a piece of text into a usable number. Take a look at this code snippet. By wrapping the input function inside the in function, we tell Python to take that user string and immediately convert it into an integer. This is how we ensure our calculations work correctly. Let's look at how we can expand our toolbox even further using modules. A module is essentially a single Python file containing reusable code. The Python standard library is a massive collection of these modules already installed on your system. We use the import keyword to tell Python we want to bring those specialized tools into our current script. Look at this snippet. By writing import math, we gain access to all the mathematical tools defined in that module. For example, using allows us to calculate a square root instantly without having to know the complex underlying formula. The import statement is the key to unlocking those specialized toolboxes we've been talking about. First, we have the basic import. By writing import math, you are essentially loading the entire math toolbox into your program. This makes every single tool within that module available for you to use, though you generally need to use the module name as a prefix. Next, We can use aliases, for example, import mass as Mayu gives the module a shorter nickname. This is very common in professional coding to save time and keep the lines of code from getting too long. Finally, we have specific imports. Writing from mass import P is like reaching into the box and grabbing just one specific tool. This keeps your workspace very organized because you only bring in exactly what you need. Let's open up the mass module. Think of this as adding a specialized drawer to our toolbox specifically for advanced calculations. Our first tool is for calculating square roots. While we could do this with basic math operators, using math.sortio is much more readable. Keep in mind that this function always returns a float. So even if you find the square root of 16, Python will give you 4.0. Next, let's look at working with powers. We've used the double asterisk operator for basic integers before, but the math.power function is built for precision with floating point numbers. Finally, this module provides us with precise mathematical constants. Instead of typing out 3.1415, you can simply call math.pi. We also have access to factorials, which are incredibly useful for statistics and probability. These built-in tools ensure your calculations are both accurate and easy for others to read. Let's look at another essential compartment in our Python toolbox, the datetime module. This module is vital for managing any chronological data within your programs. First, let's look at how we capture the present moment. By calling the function Topic09, Python fetches the current local date and the exact system time. This is incredibly useful for creating logs or timestamping user actions as they happen. However, you might often need to work with specific dates from the past or future. To do this, you can manually construct a date object by passing in the year, month, and day. Python then treats this as a precise object rather than just a simple string of text. We now need to learn how to present those dates to users and perform calculations with them. This is where formatting and time deltas come into play in our Python toolbox. First, let's look at the stripe function. I like to remember the F as standing for format. This tool allows you to turn a complex dating object into a clean readable string that anyone can understand. To use it, you provide specific codes. %y for a 4-digit year, %m for the month, and %d for the day. This allows you to customize exactly how the date appears on the screen. Next is stripe. Think of the P as pass. This is the reverse process. It's essential when you receive date information as text, perhaps from a user typing into a form, and you need to convert it into a Python object so the computer can work with it. Finally, we have time delta. This is your tool for date arithmetic. It calculates durations or offsets, allowing you to add or subtract time without worrying about how many days are in a specific month or leap years. Look at this code example. By adding a time delta of 5 days to our date d, Python automatically handles the calendar logic for us. It makes scheduling tasks incredibly simple.